Hello and welcome to this practice problem. This problem is dealing with this ion here, CHO2 with a -1 charge on it. I wanted to use this as an example because it'll allow us to look at formal charges, resonance structures, and ionic compounds and Lewis structures. So let's go ahead and start off by actually figuring out what the ionic compound, or excuse me, by actually drawing a real Lewis structure, a Lewis structure that follows all the rules. So first off, as you recall, the first thing you have to do for drawing a Lewis structure is to actually figure out the number of valence electrons for that formula. Whoops. So we gotta find out how many valence electrons carbon, hydrogen, and oxygen have. We go to the periodic table. We see carbon's over here, group 4A. It's got 4 valence electrons. Oxygen's got 6 valence electrons. Hydrogen's got 1. So we got 4 times 1, 1 times 1, and 6 times 2, because there are 2 in here. But remember, because this has got a -1 charge, we need to add an extra electron, so +1. So anyway, we got 12 equals 1 equals 4. So 4 plus 1 is 15, that's 17 plus 1, so we should have 18 valence electrons in our Lewis structure. Now we go to the rules for drawing Lewis structures. We put our least electronegative non-hydrogen element in the center, single bond, where'd it go? Single bond to all the surrounding atoms. Then we fill out the octets of the surrounding atoms. Now, at this point, let's go ahead and check the number of electrons we use. We've used 2, 4, 6, 8, 10, 12, 14, 16, 18. We've used all of our electrons. Are we done? Think about it. We aren't, because we don't have a octet around our central atom. So what do we do to add? So we've used up 18 valence electrons, so 18 minus 18. So we don't have any more to put on our central atom. So what we do is we add a double bond. So we move these electrons down here. We go hydrogen, carbon, oxygen, dot, 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 double bond, oxygen, dot, 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 dot. Now we have an octet around every atom, this atom, this atom, this atom. Of course, hydrogen doesn't get an octet. We have a Lewis structure that we like. There's one problem with this, and that is that whenever you have a ion, you need to put it in brackets and put the charge on the outside of the brackets for the Lewis structure. The reason being is because, as written right now, this particular Lewis structure without the brackets and the ion looks like it has 1 extra electron than what it should have based on these the number of valence electrons for these atoms. And so that specifies. A resonance structure for this would be, of course, the other oxygen having the double bond would look just like this. And hydrogen. So here's the resonance form for it. Notice they're pretty much identical resonance forms. So let's go ahead and calculate formal charge for all the atoms in this particular Lewis structure. Let's call this oxygen 1, this oxygen 2. So for the hydrogen in this Lewis structure, we see that we have, hydrogen first off has 1 valence electrons. 1 valence electron. It's got 1 line and 0 dots, so it ends up with a formal charge of 0. Carbon from this structure, it's got 4 valence electrons, it's got 4 lines connected to it and 0 dots, so it's also got a formal charge of 0, so that's good. Look at oxygen 1, so O1, remember we said this one was O1. We have 6 valence electrons for oxygen, we have 1 line and 6 dots. That equals a -1 formal charge. And then oxygen 2, we have 6 valence electrons, 2 lines, and 4 dots. So that is 0 formal charge. If we add up all of our formal charges, remember what it should be. It should be equal to the charge on the whole species. So all the formal charges on the atoms need to equal a charge on the species itself. 0 plus minus 1 plus 0 plus 0. All add up to minus 1, which is indeed the charge on our original species.